Step 11, right triangle trigonometry. Some of this will seem familiar because you did learn a little bit of this in geometry class a couple years ago. So first and foremost, I'd like to introduce to you SOHCAHTOA, which should come right back to you. SOHCAHTOA. Remember, if you can remember SOHCAHTOA, you can remember that sine is the opposite over the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. Tangent is the opposite over the adjacent. And here you have them all listed out. Those are our big three, but we also have our big six. And our other three trig functions that we care very much about are cosecant, secant, and cotangent. Cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. Let's practice. On the first example here, we are expected to find all 6 trig functions for theta. So that means we need to find the sine of theta, we need the cosine of theta, we need the tangent of theta, we need the cosecant of theta, we need the secant of theta, and we need the cotangent of theta. All right, here's theta right here. With respect to theta, we have to first start by labeling H, O, and A. And I always kind of remember that. Some of you might live in a neighborhood that has an HOA, a homeowners association. So HOA, which side is the H? Always opposite the 90 degrees is our hypotenuse. Opposite this angle, if I go across the triangle, opposite the angle, that's my opposite side, which makes this my adjacent side with respect to theta. So if we want to label our ratios here, sine, SOH, S-O-H, is 5 over 13. Cosine would be 12 over 13. Tangent would be O over A, 5 over 12. And then again, to find our other three, we're just taking the reciprocals. Instead of 5 over 13, it's 13 over 5, 13 over 12, 12 over 5. Pause the video and try 1B. Hopefully you successfully got these 6 trig ratios. Next, we're going to try to find the 5 remaining trig ratios when we're given one of them. So the first thing we're going to do is draw the angle theta. Here it is, right here. We know that the cosine of theta is 2 over 5, which means cosine is adjacent over the hypotenuse. So this tells us in this triangle the hypotenuse is going to be 5. And I'm going to label that hypotenuse. It tells us that the adjacent is 2. And then this is my opposite side. So we almost have the same exact problem that we just had previously, where we can say sine of theta, cosine of theta, write out our big 6, tangent of theta, cosecant, secant, cotangent. But in order to do all 6 trig ratios, you need all 3 sides. Well, we don't have all 3 sides, but it is a right triangle, and we know the Pythagorean theorem. So we don't know this side right here. We know that x squared plus 2 squared equals 5 squared. X squared plus 4 equals 25. X squared equals 21. Therefore, x equals plus or minus radical 21, but it's a length, so it has to be positive. Radical 21. So now we can actually write out our ratios. Sine is the opposite over the hypotenuse, so radical 21 over 5. Adjacent over the hypotenuse. Opposite over the adjacent. Taking the reciprocal of cosine, we have 5 over 2. The other ones are going to be a little bit more involved because when we take the reciprocal, we end up with this, and we're not allowed to leave a radical in the denominator. It's just not allowed in mathematics. So we have to rationalize it. We have to multiply by a unique form of 1, radical 21 over radical 21. So multiplying across the top, we get 5 radical 21. The square root of 21 times the square root of 21 is just 21. Cotangent, similarly, when we take the reciprocal of tangent, we have to rationalize it. So we end up with 2 radical 21 over 21. Go ahead and try guided practice number 2. You can see that initially we had a ratio for sine that was not in the proper form, so we had to rationalize it. But instead of flipping this answer for my cosecant, I went back to the beginning and flipped this because that takes you straight to radical 5 over 1. So it's just a little bit of a savings because otherwise you have to rationalize 2 times. Next, we're going to use this trig that we just learned in example 1 and 2 to actually find missing length or missing angles in triangles. First, we are given that there's a 42-degree angle. We know the hypotenuse of this triangle is 18. We know that this would be the opposite side, and this would be our adjacent side. So we need to choose a trig function that's going to help us solve this. So you can see that we do know something about the hypotenuse. It's 18. We want to know something about the adjacent. It's x. That's what they told us to find. We don't care about the opposite in this problem. We don't have information about it. They didn't ask us to find it, so we cross it out. So now we need to go back and think, SOHCAHTOA, which one of the ratios would connect A and H? And that would be cosine. So we set it up as follows. The cosine of the angle, which is 42 degrees, equals the adjacent over the hypotenuse. Now we just need to solve for x. X is not by itself because of this divided by 18. So if we multiply both sides by 18, we can punch that on the calculator, and we get 13.3766. And I don't believe it told us what to round to, but normally it's fine to go ahead and round. In fact, I should probably use my approximation since I'm rounding. 13.4. You can check this because if you put this back into your equation, 13.4 divided by 18 is 0.74. The cosine of 42 is also 0.74. So we know that we're right. One thing I want to point out is something about the degrees versus radians in your calculator. When you're using a TI calculator, you should always press the mode button and check that you are in degree mode. It's right down here. You need to make sure degree mode is highlighted if you're given something in degrees. Now, we are going to get into radians in a couple more steps, but right now we want to stay in degree mode. Notice if I go back to radian mode, if I type 18 cosine 42, I do not get 13.4. I get -7. And the reason is I'm in the wrong mode. You need to be in degree mode. And now when I type 18 cosine 42, I get the right answer. Same thing on Desmos. When you're in Desmos, you can press the little wrench in the upper corner. You want to make sure that you're using degrees. So if you were to type 18 cosine 42, we're in radian mode right now. So we need to switch to degree mode to make sure we get the right answer. Pause the video and try 3A and 3B. Both of these are pretty easy to set up, but you might have had some trouble solving. Notice that in both examples, x is in the denominator, and that's what we're trying to solve for. So the first thing we do is a rescue mission where we multiply both sides by x. That gives us x times sine of 53 equals 15. X is still not by itself, but at least it's not trapped in the denominator. Then we divide by the sine of 53 to get our answer.